The DOM Optimizer tool has been developed to optimize the track and shovel operation and save money. This application runs in Microsoft Excel and includes several macros written in Visual Basic language. The main objectives considered in the design of this tool were that it was is easy to use, user-friendly, reflects the real operation as possible, flexible to combine track and shovel types available, and low cost to implement, as only a valid Microsoft Excel license is needed. Once the Excel application is opened, the first page selected is Home. As default, this page describes a brief explanation about how this tool is used. To explain each icon of this tool, we are going to use a simple example from Track Shovel Predictive Operation. Reserves group has two icons. The first one is to import the mining reserves, and the second one is to import the done available capacities. The data comes from mining software like Vulkan, Carson, or another similar package. The procedure is to copy and paste the property data into each page. We are going to open the mine reserves. Basically, it's three passes. These three passes. This is the total material for the excavator. Copy and paste as a value. Now we are going to down reserves. We have 5 different locations and the dam capacity here. Copy it as a value in the dam reserves. The next group that we are going to use is the equipment setup. This group has 3 different icons: machine performance, truck setup, and speed limit. Machine performance. In this page, we are going to introduce the last 3 months utilization for each type of track and shovel equipment. This information should be updated on a monthly basis. This tool is going to use the average utilization for the equipment selected. The next icon is track setup. In this table, we have all information about the tracks available in the mine. The first part is technical information and comes from the equipment catalog. The second relevant information comes from the mine sign, like a dispatch system. Basically, it's a spot, dumping time, and queue time. The last icon for this group is the speed limits. In this page, declare the different speed limit according with the grade, uphill and downhill. I put here, and the loaded and empty condition. Those speed data may be different for each mine site because it depends on the road condition, road specification, and safety rules for heavy traffic. Also, in this part, we had to input the rolling resistance factor and the average waste density. The next group is travel time. In road setup, we are going to select uh, the track we want to simulate. In this case, we want to select 797 Caterpillar track, and the excavator maybe a pH for 100. Other information is the stroke load factor. We are to make an assumption, maybe 97%. The next step is to import the information from the roads. So to do that, we are to import road here. In this case, we have this information. Basically, it's a CSV file and contains the the route name, the AX north and elevation coordinates. In this case, we have around 400 something, 420 points. Here we see the graph is a little bit messy, but now we have to run the travel time. Use this icon to calculate the travel time, and that's it. We have here the travel time, the distance, the grade between the different points, and the speed limit and the rainfall, and for loaded and unloaded condition. Also here we can introduce manually the difference delays. Some delays due to the traffic intersection, stop signs, charcoals, or maybe another condition. In this case, we're going to put 15 seconds. Yeah, 20 seconds, for example. 30 seconds. Maybe nothing. Yeah. 20 seconds is an example, so really doesn't matter for now. 20 seconds, 30 seconds, maybe 5 seconds. That's it. Obviously, this delay could be put in the intersection area. Here, yes, from the roads. The next step is the cycle time group. In this stage, we are going to cache all information calculating the previous step. But before to do that, we have to go into done optimizer and complete our done capacity and our origin. That is the excavator, and this is for dump. So from my research, just select the origin, copy and paste beneath the pit origin cell. That's it. Yep. From the down research, copy, and paste special as a value and trespass. That's it. Other information that maybe we have to put here, maybe is the swell factor is 25%, and shrinkage factor could be 5%. That's it. That is complete. So now we return to the cycle time page. Here we have to generate the respective codes. Click the icon, so generate all possible combination. That means in this case we have 3 origins, and then reserve is 5 destination. So that means 3 times 5, we have 15 possible combination that we have here. So looks good. Now from that icon, and we have our data here. The table is complete. Basically have the travel distance, the travel time, this is one way, the average speed, uh, and the delays that we put. In some cases we don't put nothing, so it reflects nothing, and the total cycle time. This total cycle time includes the loading time, export time, queue time, dumping time. Okay, the final step is use an optimizer group. Basically, in this page we have the dump capacity and we have the excavator volumes. Those number reflects the truck cycle time. This calculation is performed using a linear programming to optimize and get the best distribution and obtain the minimum of truck hours possible. As a result, we can save money. Okay, so we are going to do that. The tunnel location, and here we have the best distribution. In this case, the best distribution here for this data location, all capacity is complete. Here we don't use this dump. Here we complete all capacity. Here complete all capacity, and here with a partial capacity. We have running capacity here, but here we split the volume between two locations because as a constraint the waste volume shouldn't exceed the dam capacity available. In this case, the dam capacity is 1.2 million. We can exceed this capacity. Other numbers that we have is the total truck hours necessary and the BCMs per hour is 456. It's a good number, but if you remember, the truck is a big boy. It's a Caterpillar 797. It's 360 ton capacity, and if we can check the travel distance is around 3 km, so it's consistent information. Another information that we can get is the total of track necessary for each location. Other information that we have here is the total days spent in each location for the excavator. In this case is 0. Why is 0? Let me see. Okay, this is the reason. This is a small volume, it's around 3000 BCMs. And remember that we are using a pH for 100. It's a big one.